This is my pre-algebra course. Today we're going to learn how to solve equations with parentheses. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, in my previous course, we learned all kinds of rules. We learned the commutative rule of multiplication and the commutative rule of addition. And we learned the associative rule of multiplication and the associative rule of addition. And we learned the identity rules, all kinds of rules, and you can also call those properties, by the way. But we did not learn the distributive rule. So we're going to learn that today, because that's going to be important from now until you finish your math education. But of course, if you become an engineer or scientist, it'll be important for the rest of your life. So the distributive rule says that if you multiply a number by a sum, and we show the multiplication, by the way, with parentheses. You see these parentheses here. Remember, we learned in the last couple classes that you show multiplication in algebra with parentheses. So when a letter is right next to those parentheses, that means that we're multiplying the number a by whatever's inside the parentheses. So it says that if you multiply a number by a sum, then the result is the product of the number and the first number in the sum plus the number and the second number, the product of the first number and the second number in the sum. So that's kind of a mouthful to say all that. And it's not really important at this point that you understand exactly what it means, because we're going to do so many practice problems. But we have some examples here to kind of give us an idea of what's actually going on. So we have 2 multiplied by a sum. And the distributive rule says that we can multiply 2 times 3. And we can multiply 2 times 6. And we can add those products up. So 2 times 3 is 6, and 2 times 6 is 12. Add those up and we get 18. So that's the distributive rule. Now it's important to understand that if we use PEMDAS, we can go ahead and add these numbers up and then multiply by 2. So 3 plus 6 is 9, and then 9 times 2 is 18. So we can do it that way too. But if we use the distribution rule, that works also. 2 times 3 is 6. 2 times 6 is 12, and then 6 plus 12 is 18. You get the same number. So you're probably thinking, well, who cares? I mean, why do we have to learn the distributive rule? Why can't we just add these numbers and then multiply? Well, the reason we can't do that is because in algebra, you're going to come across situations where the inside of the parentheses, as we see in example number 2, have a letter, and you cannot combine these two terms. So we just have to multiply the negative 5 into the parentheses using the distributive rule, because we cannot simplify the inner part. Remember, you cannot add an x term with a normal term. The 3x has a variable, but the negative 4 does not have a variable. So to make this easier, we're going to go ahead and rewrite the 3x minus 4 as 3x plus negative 4. That'll just make it easier to understand, because this distributive rule works with subtraction too, because you can just take the subtraction and turn it into addition, as you see here. So then negative 5 times 3x is negative 15x, and then negative 5 times negative 4 is positive 20. So that's where we actually use the distributive rule. But again, this is all just stuff that is not really that important. The important thing is that you know how to do it, and you know how to use the algebra fluently. So let's get right into the practice problems. So here we have an equation with parentheses, and there are variables on both sides, as you can see. So we know how to solve equations with variables on both sides. We learned that in the previous class. I believe it was the previous class. Actually, no, it was a couple classes ago, but whatever. So we know how to solve equations with variables on both sides, but we don't know how to solve equations with parentheses and variables all over the place. So the first step to solve an equation with parentheses is to use the distributive rule to get rid of the parentheses. So we're going to do that. So 2 times x is 2x. 2 times 4 is 8. Rewrite the minus 3. 3 times 3x is 9x, and 3 times 2 is 6. That's it. It's pretty simple. That was an easy problem because we didn't have any negative signs inside the parentheses. But we're starting off easy here, but that's pretty much what we're going to be doing for this entire class. The good news is that at this point, it's the same problem that we did in a previous class. We just solved the equation with variables on both sides. So that's the only difference between this class and the previous classes, is that you just have to use the distributive rule to get rid of the parentheses. So now when you multiply 2 times x and get 2x, you're probably thinking, well, how did we know how to do that? Well, you learned that in the course where we learned how to simplify algebraic expressions. That was course number 5, 6, I don't remember. And 3 times 3x, we learned how to do that. So that's just something that you should know. And if you don't know, we're going to review it right now. So now, at this point, we have to simplify because we can combine the 8 and the 3. So 8 minus 3 is 5. And we can also combine the 7 and the 6 because those terms don't have variables. So 7 plus 6 is 13. And I can put the 13 over here, or I can put it over here. It doesn't really matter. All right. So at this point, well, let me say this. Up to that point, we haven't done anything. We haven't performed an operation on both sides of the equation. Remember, when you perform operations on both sides of the equation, you have to rewrite the equation just to show the steps. If you don't rewrite the equation, it becomes hard to follow what you're doing. But I want you to understand that in this class, we're going to start to, and this is only in this class. It's not in any other class in this course. In this class only, I'm going to show you how to do some of these operations on both sides of the equation in your head. And the reason is, if we try to show every step of this equation, we're going to take one entire page to show every single thing. So in this class, you don't have to rewrite the equation every time you perform an operation on both sides of the equation. In fact, you don't even have to show it. You don't have to show it. So let me and this is the way you're going to do things when you get into beginning algebra, the next class after this one. So you're not going to show every single step just because it's going to become so tedious. Now again, most of the classes in this course, I want you to show every single step. I want you to rewrite on every single step. It's just this class that I'm going to allow us to get a glimpse into what it's going to be like when you go into upper math courses, and you're going to hopefully be able to relax because you're going to realize that you don't have to show every single step. So let me show you what I mean by this. I'm going to subtract 2x from both sides of the equation, and that's going to make this 2x disappear, and it's going to make this 9x become a 7x. Actually, I'm going to just write the 7x. So I subtracted 2x from both sides. I got rid of this, and this became a 7x. I'm going to do another step, so I'm going to do 2 steps at once. I'm going to subtract 13 from both sides, so that's going to make this one disappear, and 5 minus 13 is negative 8. So I did 2 steps at once, and I didn't rewrite the equation each time that I performed an operation on both sides of the equation. And I know what you're thinking. You're thinking, whoa, wait a second. You can't do that. We didn't do that in previous classes. Well, we didn't do it in previous classes because I required you to show each step. But again, this is the only class where, again, I'm going to give you a glimpse into how fast you can do this stuff. So now, and again, we didn't show what we were doing. We didn't show the steps. So now, on this step, we're going to do the same thing. We're going to divide both sides by 7, but we're not going to show the division. And the reason we're not going to show it, again, is because if you want to show every single step, it would just keep going on and on and on and on. But again, just be aware, I'm going to require you to show every step in other problems. It's just this class where I'm going to allow you to skip that. All right, so let's try number 2. Again, the first step to solving an equation with parentheses is to get rid of the parentheses. So we're going to multiply -4 into 2y, -4 into 3, or by 3. Rewrite the 5. 6 times y is 6y. 6 times -2 is -12. And there you go. We're done with the parentheses. So again, I did -4 times 2y is -8y. -4 times +3 is -12. And same thing over here. That's the distributive rule. So now we need to simplify. -12 plus 5 is -7. And -12 minus 8 is -20. So now we're going to get all the variables on one side, all the y's on one side. So we're going to add 8y to both sides, and it's going to make this disappear. And 6y plus 8y is 14y. And then we're going to simultaneously add 20 to both sides, so that's going to make this 20 disappear, and 20 plus -7 is 13. Then we're going to divide both sides by 14, and we get 13 over 14, because the 14 cancels out because we're dividing by 14. And then we divide the left side by 14 and get 13 over 14. So again, I skipped a lot of steps. I didn't show everything. Again, when you go into beginning algebra, this is how you're going to do it. This is how you're going to show your work. You're not expected to show every single step, because it would just it would drive you crazy. It's only this course that you usually have to show every step. But in this class, again, we're taking shortcuts. So the first step is to get rid of the parentheses. So why don't you try this problem? And I want you to try the first step, just the first step. And when you're done with the first step, start the video again, because I want to make sure that you do it correctly. So try the first step, use the distributive rule to get rid of the parentheses, and when you come back, we'll continue the problem. All right, we're back. So that's what you should have got on the left side of the equation. And then that's what you should have got on the right side of the equation. So if you got that, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. So now I'm going to combine the 8 and the 2 to make 10. And 12 minus 5 is 7. And so why don't you keep going with that? And when you come back, we'll do it together. All right, we're back. So we're going to add 3z to both sides to get 7z. Now you could subtract 4z from both sides, but then you'd end up with a negative, so we don't really want to do that. You can do it if you want, and it'll work. It's just we want to end up with a positive instead of a negative 7z. And then we're going to subtract 10 from both sides, and then we'll get -3 on the right side. And then we're going to divide both sides of we want to get rid of the 7, so we're going to divide both sides by 7, and we'll get -3 over 7. And so we end up with -3/7. All right, on to number 4. Now I want you to try number 4 completely on your own. And when you come back, we'll do it together. All right, we're back. -2 times 5x is -10x. Negative 2 times negative 3 is positive 6. 4 times 2x is 8x, and 4 times negative 1 is negative 4. All right, now we're going to add 10x to both sides, and we get 18x on this side. Add 4 to both sides, and you get 10 on this side. Divide both sides by 18, and you get 10 over 18. So at that point, we just have one more thing to do. We want to use the fundamental principle of fractions, divide both sides by 2, and we get 5 over 9. So if you got 5/9, that's very good. All right, on to number 5. Attempt number 5, and when you come back, we'll do it together. All right, we're back. Negative 2 times y is negative 2y. Negative 2 times 1 is negative 2. Negative 7 times 2y is negative 14y. And negative 7 times negative 3 is positive 21. We're going to add 14y to both sides, and then we'll get 12y. And we'll add 2 to both sides, and we get 23. Again, these are all things that we're doing in our head. You're only allowed to skip steps in this class, no other class. Whenever you perform an operation on both sides, you have to rewrite in other classes. This is the only one where I'm allowing you to skip that. Divide both sides by 12, and the 12 cancels out, and you end up with 23 over 12. And you can leave it as an improper fraction. So if you got 23 over 12, very good. All right, so this is a big one, but we can still do it. Go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. I'm going to make a divider line here. 7 times z is 7z. And at this point, I'm just going to do it. So double check, make sure we did everything correctly. Looks right. Now we have to combine like terms. So 7z minus 6z is z. And 21 plus 10 is 31, and 31 plus 8 is 39. So we simplified the left side of the equation. And 4 minus 8 on the right side of the equation is negative 4. And then we just rewrite the negative 12z because we can't combine a z term to a normal term. All right, so now we're going to add 12z to both sides, and we get 13z. And then subtract 39 from both sides, and we get negative 43. And then we divide both sides by 13, and we get negative 43 over 13. So if you got negative 43 over 13, very good. Now, if you're not getting those answers, that's okay. Just figure out what you did wrong. Don't get frustrated. Remember, all it takes is one mistake in algebra, and the entire answer is wrong. So it can be frustrating when you're trying to learn this notation for the first time. All right, so try number 7. Number 7 will be a lot easier. And when you come back, we'll do it together. All right, we're back. 2 times 9x is 18x. 2 times negative 5 is negative 10. And we're going to subtract 3x from both sides and add 10 to both sides. And then we're going to divide both sides by 15, and the 15 is going to cancel out here. And we have 11 over 15. So if you got 11 over 15, good job. Try number 8, and when you come back, we'll do it together. All right, we're back. Negative 5 times 3y is negative 15y. Negative 5 times negative 3 is positive 15. And 2 times y is 2y, and 2 times negative 1 is negative 2. All right, so now we're going to combine the 2 and the 15 to get 17 on the left side of the equation. and there's nothing we can combine on the right side of the equation. We're going to add 15y to both sides to get 17y, and add 2 to both sides to get 19. Now, again, you can subtract 2y from both sides to get negative 17y, and subtract 17 on both sides to get negative 19y over here. All that's going to do is just make these both negative. But we don't want to deal with the negatives if we can avoid it. So now we divide both sides by 17, and we end up with 19 over 17. So if you got 19 over 17, good job. All right, try number 9, and when you come back, we'll do it together. All right, we're back. We get 4z and we're going to subtract 4z from both sides. Oh, whoops. Before we do that, we need to simplify the left side of the equation. Always simplify before you start performing operations on both sides of the equation. 8 minus 1 is 7. So subtract 4z from both sides, and subtract 8 from both sides, and you get negative 1. And divide both sides by 2, and z is equal to negative 1/2. So if you got negative 1/2, good job. All right, try number 10. Whoops, let's see here. Number 10, that looks pretty involved. So do your best, and when you come back, we'll do it together. All right, we're back. 5 times 2x is 10x. 5 times negative 3 is negative 15. Negative 6 times 3 is negative 18. Negative 6 times negative 2x is positive 12x. So everything looks right. You may have noticed as you're doing these problems with me that signs, writing the incorrect sign is probably the most common way to make a mistake. So now we're going to combine like terms. The negative 2x and 10x becomes 8x. And 9 minus 15 is negative 6. And 3x plus 12x is 15x. So things are getting more and more simple. Let me double check that. Everything. Oh, I made a mistake. Wait, no, I didn't. That's fine. So you got to be really careful. All right, subtract 8x from both sides, and you get 7x. Add 18 to both sides, and you get 12. So now divide both sides by 7, and you get 12 over 7. It seems like every answer that we get is an improper fraction. That's no big deal. All right, now we're going to try number 11. So why don't you try this one on your own? Wait a second. I got a problem here already. I got a y there. There shouldn't be a y there. I got to change that to an x. So try this problem, and when you come back, we'll do it together. All right, we're back. And add the x's together, we get 32x and negative 2. Add these together, you get negative 2. Add 2x to both sides. Add 2 to both sides. And this time we're finally going to get a proper fraction, but unfortunately it's not reduced. So we have to use the fundamental principle of fractions, divide both sides by 2, and you get 6 over 17. So if you got 6 over 17, good job. If you got 12 over 34, it's correct. It's just you have to reduce it. So I'm going to put a divider line here. Try number 12, and when you come back, we'll do it together. All right, we're back. And combine like terms on the left side. Try to keep that negative sign lined up if you can. I'm going to move it over a little bit. Now it's lined up. It just makes it so much easier for the reader to read your work. All right, add 6z to now. Normally, to avoid the negatives, you would add 6z to both sides. But I'm gonna show you how to do it a different way, just to let you know you're still gonna get the same answer. So instead of adding 6z to both sides, I'm gonna add 2z to both sides. And subtract 25 from both sides. And then divide both sides by -4. And negative 26 divided by -4. The negative, when we divide a negative by a negative, it becomes a positive. And 26 divided by 4, we can use the fundamental principle of fractions, divide both sides by 2, and we get 13 over 2. So if I did it the other way, if I tried to put the z's on this side and the other numbers on this side, I would have gotten positive numbers, but I would have got the same answer. All right. Try number 13, and when you come back, we'll do it together. All right, we're back. So let me just double check that. Everything looks right. We can't simplify anything on the right side of the equation, but on the left side of the equation, but we can simplify stuff on the right side of the equation. All right, so we're now going to add 15x to both sides and subtract 22 from both sides. Now notice when I added 15x to negative 14x, I got 1x, but I didn't write the 1 because you don't need to write the 1. Mathematicians just let you write that as x instead of 1x because it makes it easier to write the math, to write the symbols, to show your algebra. So at that point, because x is by itself, we're done. The answer is negative 12. So if you got negative 12, good job. All right, try number 14, and when you come back, we'll do it together. All right, we're back. Negative 1 plus negative 2, or negative 1 minus 2, same thing, is negative 3. And subtract 2z from both sides, and we get z. Subtract 3 from both sides, and we get negative 6 over here. And this is the same situation. Because z doesn't have any coefficient, we're pretty much done. Z equals negative 6. There's nothing to... We isolated z. All right, so why don't you try number 15, and when you come back, we'll do it together. All right, we're back. Everything looks good. On the right side, 3x minus 8x is negative 5x. I can simplify that immediately. And negative 2x plus 8x is 6x. And negative 4 minus 12 is negative 16. And we're going to add, well, I guess we, in this case, we'll just use the negative. So subtract 6x from both sides, because it'll be one less step. And we get negative 11x over here. And then divide both sides by negative 11, and you get positive 16 over 11. So if you got 16 over 11, good job. Now 16 is different. The reason it's different is because, notice, we just have a negative sign hanging out here in front of the parentheses. Well, when you have a negative right there in front of the parentheses, it's assumed, again, just like a negative x is assumed to be negative 1 times x, when you have a negative in front of parentheses, it's assumed to be negative 1 times the parentheses. So this is no different from the problems that we completed before, except the negative 1 is just not, or the 1 is not written there, because mathematicians get lazy, I guess, and they just don't want to waste the energy writing the 1 when they can just write the negative sign. So now it's just the same old problem. So negative 1 times 3y is negative 3y. Negative 1 times negative 1 is positive 1. Rewrite the 7. And simplify on the left side of the equation to get 8. And then we're going to add 3y to both sides and subtract 8 from both sides. Over here we'll get 2y, and if we subtract 8 we actually get 0. So this is a strange problem here, because now we get 0. Divide both sides by 2, and 0 divided by 2 is just 0. So again, if you show the work here, we did this before many times. You divide both sides by 2. Any fraction, so our final answer is 0 over 2, but any fraction with 0 in the denominator just becomes 0. So that's why our answer was 0. All right. On to number 17. So why don't you try one of those problems? Remember, this is assumed to be negative 1, and when you come back, we'll do it together. All right, we're back. We're going to rewrite that as negative 1 times z plus 4. Seems like a lot to have to rewrite just to do that one thing, but I want you to be sure that I want you to be sure what's going on here. All right, negative 1 times z is negative z. Negative 1 times 4 is negative 4. Negative 2 times 3z is negative 6z. Negative 2 times negative 5 is positive 10. All right, simplify the left side of the equation. 2 minus 4 is negative 2. Negative 2 plus 1 is negative 1. And there's nothing we can do on the right side of the equation. Add 6z to both sides, and we get 5z over here. Add 1 to both sides, and we get 11 over here. And divide both sides by 5, and z is equal to 11 over 5. So if you got 11 over 5, good job. All right, try number 18, and when you come back, we'll do it together. All right, we're back, so we're just going to write that 1 in there so we understand what's going on. And we're going to write a 1 here too, because we have the same situation. So now, starting here, negative 1 times 2x is negative 2x. Negative 1 times positive 1 is negative 1. And negative 1 times x is negative x. And negative 1 times negative 3 is positive 3. Now, we're going to add 2x to both sides, and we get x. Well, actually, nope. Let me back up there. We need to simplify first. So let's combine these to negative 4. And combine these numbers to 7. And then we're going to add 2x to both sides. And subtract 7 from both sides. We get negative 11. X is equal to negative 11. So if you got negative 11, good job. All right, so now we're going to a slightly different problem, but it's pretty much the same thing. The only reason that this problem is different is because on these problems, the first term in the parentheses has a negative, but that's really not going to change much. But let's do one of these together just to make sure that you've got it. So 2 times negative 3x is negative 6x. Whoops. And 2 times 1 is 2. Negative 4 times, and here is something that that we need to pay attention to. So this is considered to be negative 1x. So negative 4 times negative 1x is positive 4x. And negative 4 times negative 3 is positive 12. So hopefully you're in agreement with all that. Add 6x to both sides. Subtract 12 from both sides. And divide both sides by 10, and we get negative 1. All right, so why don't you try, let's see here. Yeah, why don't you try number 20? When you come back, we'll do it together. All right, we're back. I simplified the left side of the equation. Subtract 8x from both sides, add 1 to both sides, and we get negative 12. So if you got negative 12, good job. All right, let's try another one of these. Go ahead and attempt 21, and when you come back, we'll do it together. All right, we're back. Let's see here. This is a problem where we have the negative 1 because there's no coefficient here. So we got to write negative 1 there. We don't have to write it, but I'm just writing it for your sake. I mean, you can go ahead and just multiply. As long as you know that that's negative 1, then you're good to go. Just go ahead and perform the operation. All right, so now we're ready. So negative 1 times negative 7y is positive 7y. Negative 1 times 7 is negative 7. And so on and so forth. Add 30y to both sides. Add 8 to both sides. Divide both sides by 37, and we get negative 4 over 37. All right, so if you got negative 34 over, or if you got negative 4 over 37, good job. Okay, so in these problems, there's only a slight difference. The x term is in the second term in the parentheses. No big deal. So let's do this one together. Negative 2 times 3 is negative 6. Negative 2 times negative 4x is positive 8x. 3 times 1 is 3, and 3 times 2x is 6x. Subtract 6x from both sides. Add 6 to both sides. Divide both sides by 2. And we get 9 over 2. All right, on to number 23. So now you try number 23. When you come back, we'll do it together. All right, we're back. Negative 5 plus 9 is 4. 4 minus 8 is negative 4. And add 6z to both sides, and you get 4z. And add 4 to both sides, and you get 8 on the left side of the equation. And divide both sides by 4, and we get 2. All right, so now try 24. When you come back, we'll do it together. All right, we're back. 2 times negative 4 is negative 8, so on and so forth. Add 2x to both sides. Subtract 3 from both sides. Divide both sides by 8, and we get negative 11 over 8. So if you got negative 11 over 8, good job. All right, try 25, and when you come back, we'll do it together. All right, we're back. This is a problem where you have negative 1 in front of the parentheses. So I'm not going to rewrite it with a negative 1. I'm just going to assume you get it by now. So negative 1 times 2 is negative 2. Negative 1 times negative 3y is positive 3y. So as you can see, all that negative does is just change both of these signs. The 2 was positive, but now it's negative. And the 3y was negative, but now it's positive. Whatever you have to do to remember that and understand it, just do it. So now negative 4 times negative 2y is positive 8y. Negative 4 times 2 is negative 8. All right, so 3y plus 3y is 6y. And 3 minus 8 is negative 5. Subtract 6y from both sides. Add 5 to both sides. Divide both sides by 2, and you get 3 over 2. Again, this is how you're going to do it when you get into upper math courses. But most of the problems in this course, you're going to have to show every step. So this is just a glimpse into how you're going to do it the fast way. All right, try number 26, and when you come back, we'll do it together. All right, we're back. Negative 2 times negative 5 is 10. Negative 2 times negative 4z is positive 8z. And then the signs just change on that like we mentioned. Again, you consider this to be negative 1. Negative 1 times z, negative 1 times 1. All right, add z to both sides, because again, this is considered to be negative 1z, so you add 1z to both sides, it cancels that out, and you get 9z over here. Subtract 10 from both sides, and you get negative 11. Divide both sides by 9, and we get negative 11 over 9. And like I mentioned before, you can put the negative in the numerator, or you can put it in the you can put it next to the fraction line. You can even put it in the denominator, but that's really unusual, so you probably don't want to do that because it's going to look weird. So if you got negative 11 over 9, good job. All right, so on to 27. Go ahead and attempt 27, and when you come back, we'll do it together. All right, we're back. So let me just double check that, make sure it's correct. Everything looks correct. Combine like terms. All right, now we're going to add 12z to both sides. Add 3 to both sides. And now we're going to divide both sides by 18, and we get negative 3 over 18. The problem is that's not reduced, because 3 and 18 both have common factors, so that means we can reduce them. So divide both of those numbers by 3. 3 divided by 3 is 1, and 18 divided by 3 is 6. So the final answer would be negative 1/6. Now if you wrote negative 3 over 18, you're not wrong. That's very good. It's just you have to keep going. One more step. All right, number 28. Go ahead and attempt that problem. Again, you have no coefficient here, so it's assumed to be 1. So try 28, and when you come back, we'll do it together. All right, we're back. So this one was kind of an easy one. It wasn't too long. Add 2 to both sides. Divide both sides by, whoops, that shouldn't be an x there. Divide both sides by 5, and you get x is equal to 1. Because 5 divided by 5 is 1, and of course 5 divided by 5 here is a 1, so it gets rid of the coefficient. So if you got 1, good job. All right, go ahead and attempt 29, and when you come back, we'll do it together. All right, we're back. Combine all those x's. 4x minus 6x is negative 2x. Negative 2x minus 2x is negative 4x. Negative 4x plus 5x is x. And we have 1, 2 there, so we're going to keep track of that 2. That's right, and then subtract 2 from both sides, and we get negative 1 for the final answer. So that one was not too bad. All right, so if you got negative 1, good job. Let's make a divider here. On number 30, go ahead and attempt number 30, and when you come back, we'll do it together. All right, we're back. So as you can see, this negative here just changes the signs of everything in the parentheses. And we can't really do much on the left side, so we just rewrite that. Got to make my 2's look like 2's. 4 minus 2 is 2, and 1x plus 1x. Remember, the coefficient on these x's is 1. It's invisible, but it's 1. So 1x plus 1x is 2x. All right, so we're going to add 3x to both sides, and we get 5x. Subtract 2 from both sides, and we get 0. This is a special problem because we're getting 0 as an answer. So divide both sides by 5, and we just have 0. So if you got 0 for that one, good job. All right, on to number 31. Go ahead and try number 31, and when you come back, we'll do it together. All right, we're back. So I'm going to go ahead and combine these terms so I don't have to rewrite more terms there. And then I'm going to go ahead and use the distributive rule on these. Again, that's called the distributive rule. You're going to have to know that name. Whoops, that's going to be a negative 18x. All right, that looks right. Can't do anything to simplify on the left side of the equation, but on the right side, negative 2x minus 18x is negative 20x, and 12 plus 3 is 15. All right, so actually, we don't have to rewrite. Add 20x to both sides, and you get 26x on the left side. Subtract 3 from both sides, and you get 12 on the right side. Divide both sides by 26, and you get 12 over 26. The only problem with that is that we can reduce it. So divide both sides by 2, and you get 6 over 13. So if you got 6 over 13, good job. If you got 12 over 26, that's a good job also. You just have to keep going. One more step. Reduce that fraction. All right. We'll put a divider line here. Go ahead and try 32, and when you come back, we'll do it together. All right, we're back. And as you can see, I went ahead and simplified that. No reason to write the 4 minus 1 again. So we're going to simplify on the left side of the equation. So negative 1x, again, this is a 1x. There's no 1 there, but it's considered to be negative 1x. So negative 1x minus 2x is negative 3x. And negative 5 plus 3 is negative 2. And we're going to add 2 to both sides. And divide both sides by negative 3. And we get negative 5 over 3. And again, you can write that negative in the numerator, or you can write it right next to the fraction sign. But I didn't have any room here, so I just wrote it in the numerator. Now you're probably wondering, how come I didn't write it in the denominator? Because the negative is on the 3. Well, again, it doesn't matter where you put it. It just matters that it's a negative. So you can put it in the numerator or wherever you want to put it. Just don't put it over here on this side, because that's not correct. So if you got negative 5/3, good job. All right, we're doing really well. Looks like we only have 2 more problems. All right, so try number 33, and when you come back, we'll do it together. All right, we're back. So we got rid of the parentheses on that first step. And now we're going to simplify. Now, I notice I put the normal number on the left and the x number on the right. I could have switched those. It really doesn't matter. Here I put the x on the left and the regular number on the other side. Again, I could have switched those. Let me show you what it would look like if I switched them. This side would be 4x minus 1. It'd be the same thing. And this side would be negative 10 plus 6x. It's just a different way of writing it. It's the same exact thing. We just switch the terms. You have to know how to put the terms on either side. Whoops, that should have been a 16x. I'm sorry. 16x. Now I'm confusing you. All right. So we're going to subtract 4x from both sides and add 10 to both sides. Divide both sides by 12, and we get 9 over 12. But if you stop there, we got to go one more step. We got to reduce. So we got to divide both sides of that fraction by 3 to reduce it. And then we get 3 over 4. So again, if you got 9 over 12, that's good. There's nothing wrong with that, except if you become an engineer and you write your fraction as 9 over 12, the engineers are going to laugh at you. They're going to say, well, why did you do that? Why don't you just write it with smaller numbers? It's a lot easier. All right, so on to the last problem here. And looks like we have an easy one for the last problem. So go ahead and try number 34. When you come back, we'll do it together. All right, we're back. Nothing to do on the left side of the equation. But on the right side, we got to use the distributive rule, and we can simplify on the right side. 4 minus 8 is negative 4. And subtract x from both sides. Subtract 2 from both sides. And divide both sides by 2, and we get negative 3. So if you got negative 3, good job. This is everything that we did today. If you'd like to take screenshots of these pages so you can use them with your homework and to study for tests, go ahead and do so. All right, let's look at the homework. Here's your homework. So get a screenshot of that. And notice you, like always, you have all the answers. So don't just do the homework correctly. And of course, do it completely. And when you're doing the homework, you can rewrite the equation every time you perform an operation on both sides of the equation. But you don't have to in this particular class. You can do some of that in your head. But if you find yourself getting confused, you can always show every step, and that might help you figure out where you're going wrong. But again, I just want to make sure you're clear. We're only rushing through the problems for this particular class, and all the other classes I'm going to require you to rewrite and show every single step. So do that homework, get it done, and I'll look forward to seeing you in the next class.